Okay, welcome back, everyone. Hello. So we are here. Hello. There we go. Hello, welcome back, everyone. We are gonna do our workshop and StarCraft competition reports, and actually saying that the wrong way around, because we'll start off with our StarCraft AI competition report. I'm sure Dave will mention this. The StarCraft competition has been going on for many years, and we're always excited to see what new things the competition participants have cooked up. So Dave, can you please take it away?
Can you hear me?
Yes.
Great. I'm getting a little bit of feedback. If you could mute your mic while I'm talking, that would be great.
Yes, I will do that.
Perfect. Okay, I'll just start talking now. So, thanks everyone. I apologize that I can't be there. My name is Dave Churchill. I'm currently at Memorial University of Newfoundland, where we're hosting the competition for the past 6-7 years now. And I'll give you the report from the StarCraft competition this year. So I've had a few questions on where Memorial is. If you're there in person, you're probably over here on the left somewhere, but I'm over here in the easternmost city in North America. So it's quite the time difference. It's actually 7:30 here. So as mentioned, this competition has been going on for 13 years. This is the 13th year now. I think this is one of, if not the longest continuously running AI competition that exists internationally. So that's pretty neat. If you want to follow along with these results, you totally can. They are currently live on my website here at this the following URL. And just as a bit of a spoiler alert, the competitors in the competition are already aware of their standings in the competition. So this is kind of old news as of about yesterday, I guess. The tournament format that we have for the competition is the full game of StarCraft Brood War. So we have Fog of War enabled, meaning that we play just like the humans do. And it's a round robin format. So we have 10 different maps that are played during the competition, and each bot plays against each other bot on every map as many times as possible. And then the bots are ranked by their final win percentage. We have some additional rules in the game that are not in the human version of StarCraft. The first is that there's a 60-minute game time limit. And the reason for that is because sometimes, if you've ever programmed an AI, sometimes it goes a little bit wrong, and maybe you can't find the enemy's last building or something like that. And so we have a 60-minute game time limit, and then we tie break with the in-game score, which is a decent metric of how many things you've produced and how many things you've killed. We don't allow any cheating or in-game glitches. We've never found anyone in the history of the competition to be using any sort of in-game glitch, so that hasn't typically been a problem. However, we do penalize bots for slow computations, and that was a little bit of a talking point this year that I'll get to toward the end of the competition. So it's a real-time strategy game. So it's not like a chess clock where you have, say, a half an hour for all of your computations throughout the game, but we do try and keep it real-time on every frame of the game. So we have, say, for example, 42 milliseconds, which is 24 frames per second, which is how StarCraft is played by humans, or at least the original version of StarCraft. So if you go over that a certain amount of times, then you will lose the game. We also have a file IO for learning. So if you faced a bot once in the first round and they rushed you, you could sort of write that out to a file and then read, hey, they rushed me last time, so maybe I should do something about that. I often get asked, why not StarCraft 2? And that used to be because we weren't allowed, but now it is allowed, and I'm just maybe a little bit lazy, and I don't want to write all the software to do StarCraft 2. But there are StarCraft 2 AI competitions out there. It's just that I'm not running those. This year, we had 11 competitors in the competition. These two down here are Dragon and Alberta bot. This is my bot. They're in gray because they were re-entered from last year's competition, because they I always re-enter my bot every year because it plays random, which sort of throws a wrench into everyone's AIs. So it's nice to have a random bot there. And there were 9 new entries to this year competition. New entries meaning they updated their bot for this year and then submitted those new entries. In terms of actual new bots, I think 2 of the 9 were new this year who have not competed before. Maybe I think it was Pylon Puller and Styx. Those two bots had never competed before. So this year, the tournament was run on 8 virtual machines. It ran for 11 or 12 days. We played about 12,000 games in total. So these 8 machines can play about 1,000 games per day. That's 2,200 games per bot, 220 games per bot pairing, and 22 games per bot pairing per map. And so that's a lot of games. We can gather some hopefully statistical significant results from that many games. This is something I showed last year, how, we have a 13-year history with this competition now, and I won't get into any details. I've only got about 15 minutes, but it's safe to say that there are a lot of bots in these competitions who have inherited traits or source code from other bots. So we have this really nice like family tree going every year, and I try to add to those as new bots come along. So on to the results. I like to show this graph. It might be a little bit small on your screen. I apologize, but hopefully you can see these lines. That's the important part. The really cool thing here is that for the first 60 rounds of the competition, so that's about 4 days, I guess, there was one bot who was in the lead. And then they switched at about round 60 and then stayed in first and second place. So the competition was very, very, very tight for first place for a few days, which was really cool. Then we have another cluster of the second, third, and fourth place bots. And the 5th, 6th, 7th place bots are also very, very, very close. And you can see here that some of the bots, like this orange line, for example, go up over time. And that is typically an example of when a bot does, say, strategic learning over time throughout the competition, where around round 30, this bot went from, say, a 55% win rate to maybe a 64% win rate by the end of the tournament, which is really cool. Sometimes in StarCraft, we see that there are sort of rock, paper, scissors matches because real-time strategy games have, rushing, expanding, defending, that sort of thing. And so one of those beats the other. You get like a rock, paper, scissors. And we found in this year's competition, there was no rock, paper, scissors between the bots. It was pretty much, if you were, your final ranking pretty much determined who you beat. And actually, if we look at this table of anonymized results, the first place bot in this competition did not have a less than 50% win rate against anyone else. So the first place bot was definitely in first. There was no other bot that beat the first place bot. And the second place bot only lost to the first place bot. So it was pretty clear that first and second were well above everyone else in this competition. So drum roll if you're there, I guess. These are the results for the competition. So our first place bot this year was Banana Brain, and that bot is the first time they've won the competition. So congratulations to Banana Brain. I will give some details about Banana Brain in the following slides. They came second place last year. Stardust was in second, came first place last year. Dragon was in third this year, was also in third place last year, and Steamhammer was in fourth place this year and was in fourth place last year. Purple Wave finished just behind fourth place in a very close fifth place, and they actually were not in the competition last year, but Purple Wave is a very strong bot that has been competing over a number of years and usually comes very, very close to the top, but we'll talk about that in a little bit. So the first place bot, Banana Brain, Johan is a software engineer, and the Banana Brain bot has been in development for just over 5 years, and he claims that there are 38,000 lines of code in this bot. So if you're wondering what it takes to win a StarCraft competition, lots of lines of code right now is a good benchmark for that, I guess. The bot was written completely from scratch, so it did not use any other bots as a initial source code repo. And if you want to know more details about Banana Brain, you can go to its Liquipedia page. But just for a few things, I sent a questionnaire to Johan, and he was able to answer these questions. So for example, why did you choose the Protoss race? And he said, I've been playing StarCraft for a long time, and Protoss was always my favorite race. Also, when I started development, Protoss was the least represented of the top bots, and this is no longer the case. And we'll show that it's really no longer the case. I think if I go back to the registrants for this competition real quick, all of the new submissions for this year were either Zerg or Protoss. So why that is, I'm not exactly sure. Maybe Terran are harder to program, but all of the bots were either Zerg or Protoss this year of the ones who submitted new. So in terms of strategy that Banana Brain uses, Banana Brain includes a variety of strategies ranging from aggressive to defensive or greedy. I chose to do this in order to have a higher chance of having a strategy that is capable of beating a particular opponent. So unlike Stardust, who came in second place, Stardust last year when they won, they said that what they do is have a single really well programmed strategy that sort of adapts as it sees what its opponents are doing. But Banana Brain chooses instead to sort of exploit the competition itself. It has a number of different strategies, and then it chooses which strategy based on their opponent and based on the win rate over time. And you could see that in the win rate graph. In terms of AI methodology, Banana Brain uses jump point search for some pathfinding. It does pathfinding using jump point search when it has to retreat from a path and it wants a safe path. It uses a combination of A star and potential fields for positioning during combat. It uses learning IO, so it writes out after a round of after a round of the competition, and then uses that data that it learned throughout the competition to do strategy selection for future rounds. And it also uses the Brood War Enhanced Map Library, I think that's what it stands for its map analysis. So things like detecting choke points, Voronoi diagrams, region selection, all sorts of things. So here are the full results for the competition. If you go on the website, you can see even more detailed results. So these are the rankings of the bot in order of their final win percentage. You can see here after 5 years or so, Alberta bot is still, that's my bot in case you weren't aware, is still sort of doing okay. So that's nice. However, there's two columns here that are not being shown, and here they are now, which is the crashes column and the frame timeout column. And so a lot of bots this year experienced problems with timing out. And the reason for that, I believe, is because of the way that, well, it's a combination of their bots probably not trying to be a little bit greedy with the computation, going really close to that timeout limit of 55 milliseconds when they should be maybe stopping a bit before that, but also because this competition is being run on a bunch of virtual machines, and they don't have access to those virtual machines to do adequate testing. So because of this, what I'm actually going to do this year for the first time in a long time is I scrounged up some hardware, and I'm going to run a second version of the competition on physical hardware. So I'm going to be running the bare metal version of this competition, maybe sometime in December or something like that, for the bots who feel like they were maybe a bit shortchanged by the fact that they timed out so much. So the frequently asked questions that I always get, so you don't need to ask them: how long until we beat humans? 12 years ago, I said 5 years from now. That was a bit of an oops. Computers cheat, they click really fast. Yep, and they still can't beat the world's best humans. But all these bots are rule-based. Most of them rely on rules for the most part. There's more simulation and search and learning going into these bots over time. But even if they were all rule-based, okay, you go write one if you're so good. It's a lot of work and it's really difficult. And of course, everyone says, what about AlphaStar, this thing that Google made that cost them probably tens, if not hundreds of millions of dollars? So AlphaStar, as far as I know, as of right now, still hasn't beaten the world champion on arbitrary maps using an arbitrary race, but they have beaten professional players. So AlphaStar, I would say, is the best StarCraft AI out there for StarCraft 2, at least. But consider this. Is that Google DeepMind's operating losses in 2018 were almost double the budget of my university. So it's very difficult to catch up to their scale. And unlike maybe some people attending the conference, I think that we should be stepping away from deep learning a little bit, because if we still want to have a planet in a little while, we maybe don't want to use that much electricity. So even if AlphaStar is the best, we still want to find good methods that don't destroy the world. So there we go. Lots of time for questions and discussion, hopefully. So I'll open it up to the floor for that.
Hello, everyone. It's good to see you again. So we are here to present the report of the Experimental AI in Games workshop that happened on Monday and Tuesdays. I'm Lucas, this is Madcore, and this is Shai. So for those of you who have never heard about EXAG as a workshop, we are interested in innovative applications of AI that present interesting ideas for developers, critics, players, and designers in all aspects of games and game development. Well, traditional topics that we see at AIIDE are like new game systems made possible by AI. For instance, Third Eye Crimes visualization of AI logic, or NXplore's PCG dungeon generation. We also have seen stuff like traditional AI techniques applied in new ways to break general convention, like black and white learning scripture or Left 4 Dead drama management. We also have seen the use of AI in support of mixed initiative, co-creative play experiences, including collaborative storytelling games such as Bad News. This year, we had a wide range of topics. I must say that AIIDE, accepts topics in all areas of experimental AI in games. So the range of topics this year ranges from story world generation to level reachability testing, all the way to reinforcement learning for fighting games AI.
All right. Cool. So quick breakdown. So this is I guess this is not. But anyway, I can just talk loud. Okay, here we go. All right, yeah. So this is like a historical breakdown of the conference from like the first year all the way up to our year up at the top in orange. So we had 15 papers accepted this year and then 1 demo. And then we had like a pretty big focus on trying to make sure that this was a decent like hybrid event, because we had a lot of folks that were in the UK that couldn't make it over here now. So we wanted to make sure that they could at least like engage in the talks, like see the talks as well as like give any of their talks. So if you were here, you saw that we had like this whole like wannabe AV setup that was like very like roll your own, but somehow it managed to work. But yeah, it was pretty good. If you're wondering what that's going towards, when I finish like editing and like chopping up the video, it's going to wind up looking something like this, and it's going to go on the YouTube page. So if you haven't seen our YouTube page, we have some videos from like previous years, but the camera just doesn't quite catch the slides. So you get a lot of like the audio, but none of like the visuals. So I'm going to go through, I've got like video of all the speakers as well as like screen recordings of all the slides. We're going to edit it on this like nice template and give it this very like GDC type feel. It's not going to be as cool as GDC, but like we're going to get there. We also messed around and like redid the website. So we tried to do something that was a little bit more, they say like maybe like democratic for like some of the future organizers. So this is like hosted on GitHub. So if you're organizing it next year, you can just sort of add yourself as a collaborator to it and like make all your changes and push it. And it's all hosted on GitHub pages, which just makes our life a whole lot easier. And then finally, this is a little fun like side project was laptop stickers. So if you haven't gotten one, I have like a few left. So like come and see me. Yeah, we just wanted something fun that you could like take with you, stick on your laptop or like wherever, and like remind yourself of like the fun that you had at XSAG this year.
All right. So we tried to match this year's AIIDE theme, which was misspun tales, and that was a bit of a misspun tale. So no misspun tales. So if you were, yeah, I guess I should probably mention what we mean by misspun tales. So we were the theme of this year's AIIDE was trying to report negative results and the stories behind them so that people can learn from their mistakes. And out of all of the submissions, we had no negative results, which I mean is usually a good thing. But we definitely see the value in learning from failure and like wanting to present these stories. So we hope we can sort of try to learn from this and figure out how do we encourage people to like submit things that did not quite work. So in terms of the breakdown of paper submissions, we had 22 papers, 21 research track, and 1 demo track. We accepted about 15 research papers and 1 demo. So 70% acceptance rate for the research and 100% for the demos. So yeah, that's like the breakdown of the paper submissions. For the demos, we had 1 formal demo, which was the NPC behaviors with symbolic reasoning. And then we had 2 informal demo sessions, which we thought went well, where we asked people if they had something that they were working on, they wanted feedback, some eyeballs on it, discussion starters and stuff like that to sort of take the stage and present on it. And I think we had pretty good engagement, and we were happy to see that. And we would like, Exact to be the space where, we have people are comfortable to come and talk about things that they're working on that they might develop to another system or a paper. And so we were happy to see that people were engaging in that. We could not have done this without our wonderful PCs. You are all the best PC members in our hearts. And yes, thank you so much. We cannot thank you enough. Hopefully we can see you all in the next year's AIIDE. This is our contact information if you want to add us, at us. And I guess if you have any questions, please feel free to ask us. And thank you so much.
All right, so this year we ran Intelligent Narrative Technologies. You can have the link to the workshop, QR code there if you're interested. I'll put up the proceedings when they are available. For those of you who are not, who are maybe new to the conference or haven't experienced AIIDE before, this is a quick description of what's going on. This year, I ran and along with Mike Trainer from American University and Ben Samuel from University of New Orleans. And this is on the website, if you want to check it out. Put together a brief history of INTS. INT's been offered 13 times in total. Started off as a AAAI symposium series for both the fall and the spring, and then hopped between FDG, AIIDE, ELO, and was even AIIDE and co-located with a few other workshops over the years, including social believability in games and Wicked, which I don't remember exactly what that stands for at the moment, but
The C is for
camera.
camera.
Ah, gotcha. Yeah. And so we have various websites and proceedings. I'll probably put this up on the website if folks are interested in any bit of INT archaeology. This year, we had, we'll be showing the details in just a moment, but we had a half-day workshop consisting of 2 presentation sessions of 5 papers each. So we had a nice half hour for each paper. We really got to dig in and discuss. And then we had a panel discussion, which really turned into a round the room discussion, which worked rather well. It's kind of one of those like nice workshop goals and everyone starts discussing and getting involved. But this year we had 5 papers, MPC Engine, a high performance modular domain agnostic MCTS framework for emergent narrative, visual story generation based on emotional and keyword scheme, mice in the machine, creating a computational model of novelist techniques towards generating quest narratives using player behavior, and intelligent de-escalation training via emotion-inspired narrative planning. So we had a really interesting range of papers. Very often in workshops, it's hard to touch all the corners of your workshop, but we explored the space fairly well for 5 papers. And I should note, INTS, we had we got kind of lucky. We had 5 submissions and all 5 papers were well received by the PC. So we definitely want to increase this number in the future, but it turned out very well for us this time around. And a bit about the topics. So we had AR agents with emotional planning. We had quest generation. We had novelist methods for structuring stories. We had MCTS for agent behavior. We had machine learning for mixed initiative story generation, where an author could play with the generated stories and images to help tailor the story. And so this is already a pretty large variety of interactive narrative technologies and approaches. On top of this, and I was personally happy by this, we had a really also strong exploration of the space of planning from Monte Carlo tree search to the Able Reactive Planner and Sabre. It made some really interesting discussions for the panel where we could really talk across the systems and approaches. And so in going forward, so after a bit of a lull, interest is growing. As you could, as you can see here, we were yearly for a very long time and then started being every other year. So we'll have to see how interest goes in the future and see what the cadence of future intelligent narrative technology workshops will be. So is interest growing? We'll have to see what cadence we have the workshop for every other year, every year. And this is an opportunity to continue to build community interest in the area. All right, so that's what I have for you. Thank you. And thanks to all the authors, viewers, attendees, and for listening to me right here, right now. Once again, the link to the paper, and please check it out. Thanks.
Okay, so welcome everybody. I'm Michael Gore. Out of Edmonton. Maybe this minimize that. Can you still hear me? Is that okay? Yeah, I get some feedback here, so I'm dealing with my volume. So is it okay? All right. Okay. So welcome everybody. This is Michael Burrow from Edmonton. I'm the co-organizer of the strategy AI for strategy games workshop at AIIDE. I think I just counted. This is like the 10th time we do this, right? So the 10th incarnation of this workshop. This year it was a combined workshop, combined with esports analytics. They would unfortunately this workshop didn't receive papers at all. So we combined forces. So we have an invited talk, industry talk. I'll talk about the details later on. But in the gist of it, we combined these two workshops into a single full-time event. So there's Derek Martin who helped me organize the SG part, and there's Ben Watson and Erica Kleiman who were in charge of the EA part. So if I'm totally running out of time and you would like to look at the details, I think the papers are on my webpage and everything else too. So then you may want to go write this down, or I don't know. Yeah. So anyway, so here's the website of the workshop with all the details. It looks like this. It gets updated as we go, and I will come to this back in a moment. So let me just get the time right here. 10, 16, 50, 10. And okay, so let's jump into some details. So what are the workshop goals? I think it hasn't changed much for the SG workshop over the years. It started off by looking at RTS game AI, but when we broadened it a little bit a few years ago to entertain other AIs, other games we were interested in, developing AI systems for. So, and our goal was to bring together AI researchers and AI programs for industry, and let them connect and exchange ideas on how to improve AI systems for games, for video games in particular. So over the years, we didn't have much interaction in this workshop with industry folks, but we're sending students into industry. That's a nice thing. So they get to show their work in this workshop, and people take notice. And so that's what the SG workshop is trying to do. And the esports analytics part is trying to look at tons of player data and trying to help players to improve. That's maybe in a nutshell. So I'm not an expert in EA, and I think Ben and Erica are not even present like that to answer questions. So bear with me with my ignorance about EA. But I watched the presentations. I liked it very much, like the invited presentation we'll talk about in a minute. So it's very interesting. And to fast forward to the end. In the end, there was a discussion about how to increase interest for EA, esports analytics in AIIDE as a workshops, and so we bounced off some ideas. And obviously there are some connections about with AI. My question was, well, how can we use this terabytes of data, gameplay data, to improve AI systems? So there's an angle also for not just helping humans to play better using stats, right? But also kind of feed us into improving AI systems. All right, so 26 workshop attendees, and it was a hybrid format. Oh my, I say here on the right, because there were some hiccups. To start off with LA traffic problems, right? So we have some local speakers, and they, of course, Google was off by half hour and estimating the arrival time, so we had to juggle a few presentations. But I think in the end it worked out well. We had sprinkled in some breaks, and so we shortened them. We moved things around. So in the end, everybody presented, and everything was fine. Even though I think the invited speaker was 25 minutes late or something. So it all worked out. All right, and so we used Google Meet and the conference room, and there was AV problems and whatnot. But in the end, as I mentioned, like, everything worked out. So I think we had 6 papers submitted to our workshop. We accepted 3 and to the SG workshop, and then there was 1 industry talk, like an esports talk, and I mentioned. And what we have like started with, I think 3 years ago, we call it show and tell sessions, where we invite students to present their work. Right? It's not full-fledged published work yet. It's not a official like workshop paper that gets reviewed or accepted. And so here we are asking them to, it could even be ad hoc, like when it was like 3 years ago, we did this, or 4, we did this the first time. We just asked people in the audience, hey, like, do you want to tell about the research? Somebody goes up to the whiteboard and scribbles something and draws some diagrams and whatnot. So we call this show and tell. And we had quite a few, 5 of them, 1 from SG and 1 from EA. So we also historically have like the StarCraft AI competition, or just a report I just saw, watched like Dave presenting in the main conference. So I will not go into details. You just saw it, so there's no point in me going over that, of course. And in the end, we had a group discussion about future work, and there's this one theme, programmatic strategies. We'll talk about later on a little bit, that went through like all of these discussions almost. And in the end, we ended up discussing more about programmatic strategies and also about the future of EA at AIIDE. So there was that. So I think I have prepared way too much material. With Derek, we spent, I think, 2 or 3 hours to compile these things. So it's good to have, as a summary of the workshop, but it's way too much material. So I will be choosing like a few of those like papers, maybe like describe them a little bit more detail, but I will have no time to look at everything, of course. But I just mentioned this, programmatic strategies was one of the themes of the workshop. I think there was 2 or 3 submissions regarding these strategies, like what is it? And you can think about this as search in program space. Like in the old days, like, I don't know, 20 years ago, there was genetic algorithms. Well, here's a gene thing or whatnot, but then there's also genetic programming that would like look at programs as syntax trees, and then like switch out subtrees to create offspring and stuff. So it's basically like, it's very similar to that. But it's a new view on this kind of like optimization, like way of optimizing programs. So here's an example. We're using RTS games. Like here's a micro RTS environment, a simple Java-based simulator, and here is an example. Here's a program that no programmer wrote. It's just a program that came out of this optimization process that I just described by changing like programs line by line or switching out like subtrees of like bytes of the syntax tree. And so it could look like this. So we have a syntax, we have a programming language, and then we're changing things like the order of instructions and parameters and whatnot. So, and here's an instance of a player that can play like this particular micro RTS game. It looks weird, and you have to know a little bit like what we actually do. This program computes actions for each unit, and some of these functions may fail in assigning actions to units, and then we'll just wait until the first time a unit gets assigned an action, and that will be executed the next time the environment is asking us for this action. So that looks like a funny program, but it actually plays decently. So I'm not going on about details here, but you can think of it as search in program space, and we call this programmatic strategies, right? And so, and actually, I think maybe Dave mentioned this too just now. The winning entries, or even all entries in the StarCraft competitions, are still programs, like expert programmers maybe like wrote, right? And so here's like 38,000 lines of C++ code. That is, that is the current winner, this year's winner. Okay, somebody's a good player and a good programmer, and they're combining, I think, ideas, and so now out pops a program they play. So hardly ever do we see machine learned approaches in RTS games like AlphaStar. Well, because we have fewer resources. I think Dave talked about this to some length. Okay, so and we got a few papers, and I'm not into many details here, so I'm just like referring you to maybe the link and this document I'll put up on the web page. So there's various ways of climbing this hill, like of improving programs. One is to given an opponent strategy, find a best response strategy, like a program that best responds to a given strategy. So there's things like known algorithms, fictitious play, for instance, double oracle. Here in this paper, we see something new: neighborhood, curriculum, like strategy NC, and that greedily selects from a group of strategies. So here's a new way of climbing the hill and actually defeating existing like benchmark players or baseline players. So this is just one idea. Then I think Levy in the show and tell session looked at a two-level approach, and he saw when in this optimization process he saw like lots of flat spaces where no progress can be measured at all, and he was looking at like tie breaking. So how can I tie break? So if I change a line in the program, I will still probably lose all the games against a half decent program. So here's his way of introducing a tiebreaker by looking at a two-level optimization problem. One is kind of in charge. The first upper level is in charge of the tiebreaker for the second level, and the second level may just do this hill climbing informed by the high-level choice. So here's one idea of climbing this hill faster. There was a paper that used inductive logic programming to extract tactics in chess. Things like forks and pins can be expressed as first order logic expressions, and then you can do like inductive logic programming, ILP, and we have this like solver here. They used Popper, and to come up with rules, tactical rules, right? And then they would just compare how these rules do by using chess engines like Stockfish, for instance. It's a world champion chess program that would be able to analyze these move sequences or these tactics they would come up with by analyzing human chess data. That was interesting. So second part was the esports analytics part. So there's we have tons of data, like right here, and like maybe the main aim is to improve human game playing experiences. So it doesn't have to be just like win rate, like or playing strengths. It could also be something like, I'm enjoying the game more. Like how can I make human players enjoy the game more? Maybe some people would just like to have like the invited speaker, which is just would like to have this win button. They never mind improving or anything. Just give me this win button, right? And then they push it and we'll be happy. So so winning is not everything, of course. And so he gave a good presentation. I like the first time I looked at this. He's a former member of Mybolytics, a company devoted to help players improve by looking at tons of data and different, like hundreds of different player metrics they have, and they will even have some simulation environment where they track how fast humans can, like the player can react. So they have their little mini games and would just to calibrate the system and to measure something about specific players. So it's not like all data generated from actual games, but they have their own little mini games to extract information they find useful. And so this is quite interesting. So they had big studies of 2 million players and got to the result saying people who used their system would learn, like climb the ladder faster than people who don't. So as a statistical data point saying, wow, this really helps, we're doing the right thing, and players can actually use this information. So I like this very, very much. So let's see, how are we doing in time? 12 minutes. So I guess I have to speed up a little bit, too many details. So there's one paper here, the one E8 show and tell paper looked at how could we like create a spectator system. So like in a sports game, like where should the camera look, right? I'd like to optimize that. And so they used a neural network, trained it on on professional and footage, actually on spectator footage, and compared this with rule-based systems I think they had and behavior cloning, and they found that their machine learned system works better. There is the other theme, the third theme, AI for strategy games. So basically now back to improving AI, the AI strengths in playing games. We had a few games looked at, like Baba is Smart, like Baba is You. I didn't know about this game. Do you know this game? I didn't know. It's rather interesting. I was aware, like I was familiar with Sokoban. This is hair raising. Like the graphics, I guess, could be improved, but I think this is just a simulator anyway. But you see something like like wall is stop, for instance. You can move these items, and now you're creating these triples, and they change the rules in the game. All of a sudden, if you push these guys like and form wall is up, as I understand it, now all of a sudden the game dynamics changes. Now all of a sudden you cannot go through walls anymore. So kind of interesting. So while playing the game, you're changing the rules of the game. So and so what they did, they compared a standard search algorithm IDA star with some machine learning algorithms, and they found their IDA star bot like it's dominating that. So that was interesting. Probably a student project. So now another theme was actually to make machine learning or neural network training work in games with variable like actions. So no longer do we have like 8 actions or 4 actions as for Atari games, for instance. Now we have maybe, I don't know, 1 million actions. So 500 actions, depends on the stage. So how do we do this? And there were 2 papers looking at transformers to do this. So kind of modeling like this action, the computation task as an LLP problem, which just scales, right? So now basically the output would be maybe, or the input would be, I don't know, here's n units, and the output would be n actions, right? Where n is not fixed, right? And this goes beyond like simple neural networks with a fixed input and output size. Now, right, and so I think I'm running out of time shortly. There was a paper on like content generation, procedural content generation in the game of Safari Rush Hour, which is like, you may know the original Rush Hour game where you have a car parked in a parking lot and we're trying to get out. And these cars can only go, like the horizontal cars can only go horizontal and the vertical cars can only go vertical. This is like a play on this scheme now. The guy that has to get out is this big rover, the Safari rover. These are all animals, right? And so the Safari rover has to get out, and the Safari can go like up and down, left and right. And so here's it's an exercise in iterating the entire state space, trying to solve each instance by cleverly encoding this and using standard search algorithms like BFS or A star, IDA star, and retrograde analysis to come up with the solution length for particular instances. And the goal is eventually to run this on a supercomputer and solve the entire game. Right? There's, I don't know, the computations, like actually it is feasible. Another question, of course, becomes what makes interesting positions, and the current view is, yeah, let's concentrate on the ones with the largest like length, solution length, where this is maybe debatable in whether this is actually a good idea. So there was the StarCraft competition we have already covered, I think, and there was this final session about like more discussion about programmatic strategies, and Costa Hong was describing his RL implement library. And so if you ever want to use PPO, like look at this at his library now. It's on GitHub. I think it's just 1 file, super fast compared with other popular implementations. So that's something to look at. Lastly, we looked at like the future of EA and at the AIIDE as a workshop. Maybe a rebranding will do. Maybe when people hear like, I don't know, esports analytics, it's like what is the AI part and what? Or maybe just like, you know, calling the chart different would solve half of the problems. And so as I mentioned, there's the sections to AI and also helping humans to play. So I think it has a room here as a workshop, but it's not entirely clear how they will proceed with that. I think this is all the time I have. Thank you for listening to me, and I'm taking questions. Hopefully this works. If Marcus is relaying this to